Hi there, chemistry students. We have a synthesis question here. It's a synthesis of paracetamol. It's related to benzene and it's also related to kind of nitrogen compounds. Year 2 question. As I say, very involved. Let's get started. We need to be aware of multi-step synthesis. It's going to be one that you possibly haven't seen before. You need to be aware of reagent conditions, balancing equations, mole calculations and mechanisms. You'll need this information for the majority of the questions, so you might want to take a photograph of it, have a read and have a go at the first part. Press play when you're ready for the answer. Okay, so welcome back. We've got phenol going into a nitrophenol in step 1. You need to be aware of this mechanism itself, the nitration of benzene. It's an electrophilic substitution reaction. Okay. So for step 2, another reagents and conditions question here. We're going from a nitro group to an amine group. You just have to know the balanced equation. So let's take a look at that. We can balance for oxygens with H2Os. We can balance for hydrogen with H in square brackets from some sort of a reducing agent. Alternatively, it was perfectly acceptable as a balance of hydrogens. So take a look at the next part of this question, pause the video and press play when you are ready. So here they've given you a mechanism which you possibly haven't seen before. It's a little bit more involved. So we've got our RNH2 amine attacking in the first stage, and we've got the C double bond O breaking. So from the first 2 arrows, we've already got some information about what our intermediate product would be. So the C double bond O breaking becomes a C single bond O, and now that oxygen has got a full negative charge and it's got that lone pair of electrons on it. In the first stage, we've also got the lone pair of electrons on the nitrogen forming a bond to the carbon, and now that the nitrogen is making 4 bonds, it's got a full positive charge on it. The C double bond O actually exists in the final product, so we can see that the lone pair of electrons on the oxygen in the intermediate is going to reform that carbon to carbon double bond. And there's no chlorine in the final product, so the C to Cl bond is going to break. The nitrogen is neutral in our final substance, so it must have gained some electrons, and that's probably come from, or that has come from, the NH bond breaking there with those electrons going to the nitrogen. You could have represented how the hydrogen atom is mopped up with our amine, but it wasn't required in the mark scheme. But that would be an illustration, or that illustrates there in red how the NH2 can mop up that other hydrogen atom. So go to our final product. We've restored the C double bond O. We've got nitrogen now making 3 bonds. That's the 2 marks of the mechanism. Have a read of the question. You either know this one or you don't. Factual content. Press play when you're ready for the answer. Okay, so ethanol chloride is not used. The reason for that is it makes HCl, forms HCl fumes, which are not very nice at all. You either don't know it or you don't. Okay, take a look at the question, have a go, press play when you're ready. Welcome back. This is just a reagents and conditions question. You have to know that as well as the amine being able to react, the phenol group can also react. So possibly we can make the ester. Alternatively, you could have said that it will form the ester and it will also make the amide. Have a look, pause the video, press play when you're ready for the answer. So simply a balancing equations question here. we need to make the paracetamol from hydroquinone. So the first stage is to know what ammonium ethanoate is. If we've got that, we can have a fighting chance of balancing the equation. So the ethanoate ion, CH3COO- and ammonium is NH4+. So there's that ammonium ethanoate salt. To balance it, again, we can balance with water, but at this situation, if you're not sure, you could just simply figure out which atoms you have left over, and water is a good suggestion. There it is, which is being balanced. We've made the product, we've got the hydroquinone, we know what ammonium ethanoate is, balance for atoms, and we have 2 H2Os remaining. Take a look at the question, pause the video, attempt the calculation, press play when you're ready for the answer. Okay, welcome back. I think you know that I'm going to say that it's essential that you show you're working out thoroughly and clearly. It's not a percentage yield calculation. We can assume that it's a one-to-one reaction from the scheme that we were given previously, the reaction scheme. So we can work out the amount of paracetamol. We can work out the amount of hydroquinone. It's mass over molar mass. Because it's a one-to-one reaction, the hydroquinone amount is equal to the paracetamol amount. We can work out the mass by using the formula mass is equal to number of moles times by molar mass. We simply have to put in the numbers, but don't forget to convert your kilograms to grams. There's the substituted in there, the amount. I've just left it as 250,000 over 110. That's given me a mass in grams. You could have left it in kilograms throughout if you preferred, but for 3 significant figures, that is 182 kilograms.